everybody. On my workbench today is this lovely N-gauge model of Hunslet's wartime design of 060 saddletank known as the Austerity class. The model is made by EFE Rail, which is one of Bachmann's brands, and my first impressions of it are that it's really very lovely indeed. It does feel quite light, but there are lots of fine details, and it's certainly streets ahead of the old Graham Farish model of the same prototype that hasn't been available for around 20 years. Inevitably there are one or two compromises to mass production, but this is a great starting point for conversion to 2mm Finescale. So, with such a great looking model, what else is there to do but pull it all to bits and find out how it works? I'm hoping this screw at the front will release the keeper plate. I've not had this model in pieces before, but with a bit of wiggling and pressure, away it comes. It's got the brake blocks attached to it, and underneath we can see a split frame chassis and the axles running in separate bearings, so this is looking very promising. I'm just going to find every screw that I can possibly take out now. The cab's come off. The coal I think should have probably come with it, but must be still attached underneath. There's a screw down the chimney that releases the saddle tank with more hidden mechanism underneath. Let's see what else we can find. So that screw at the back has released part of the footplate. We can take off this sellotape, and there's another screw underneath. So 5 screws to release this cover, which I assume is holding the motor in place. I'm not too worried about what happens to that decoder socket and blanking plug at the moment. If I do fit this loco for DCC, I'll probably hardwire a decoder at some point. So, underneath this cover is a small coreless motor with a worm attached directly to it. And it feels like with a bit of judicious wiggling I should be able to get this boiler unit to come away and separate the motor from the rest of the drivetrain. I can't see any more screws to undo, so I'm wondering now if the footplate should be able to wriggle its way off the chassis block. I'm going very carefully with this because I don't want to snap the footplate. It's quite a tight fit. Once I've snipped these 2 wires, I'm left with a rolling chassis, and at this point I have to make a decision. Do I want to try and replace the wheels in the chassis with 2mm Finescale ones, or do I want to replace the chassis in its entirety? The axles can be removed from the chassis by pulling them out. The bearings are a tight push fit into the chassis block, and this wheel set could be replaced like for like with 2mm Finescale version, but that's not the approach I'm going to take on this occasion. I would, however, like to reuse this motor, so I'll see if it's possible to replace the worm on it with one from the 2mm scale association that will match the association's range of gears. I'll need to use a gear puller to remove the worm without damaging the motor shaft. Mine's made by GWS, but if you do a quick search on the internet you'll find many similar ones available. So this etch from the 2mm association is going to form the basis of my new chassis. We can see it's got some pieces for the side frames and some strengtheners, buffer beams and other detailing parts like sandboxes to fold up, a box to assemble the frame in if you wish, brakes, brake pull rods, coupling rods and balance weights for the wheels. As well as the etched pieces, we're going to need some other components from the association shop. However, this fold-up gearbox that came with the etch is not going to be required. I have another project in mind for that though. What we do need are some phosphor bronze bearings which will be soldered into the chassis side frames, some wheels, and by the time this video goes out live, the new production ones should be available in the 2mm association shop with brass centres and steel axles. We've got some crank pins that will fit into the wheels, some muffs to hold the wheels apart, different shapes and sizes, some for mounting gears on. Speaking of which, we've got a set of spur gears and also the worm and worm gear that are recommended for this chassis. The worm wheel fits onto this muff with the flange, which separates it from the smaller spur gear that goes next to it. I've also got a set of etched crankpin cap washers here to solder onto the crankpins once the rods have gone on them. We've got a length of axle steel, which we're going to have to make stub axles out of, and will also be useful for aligning the frames. And then finally, some PCB frame spacer material. This comes in 2 different widths, and we'll choose which one to use according to how thick the frames are. I'm going to begin by cutting out the main frames. I'm using a scalpel to do this, and I'm cutting onto a piece of hardboard so that the etch is supported underneath. When I press down with the knife, I don't want to distort the metal. There are a series of half-etched tabs around the edge of each part, and it's just a case of finding them and then cutting down through them. Now when I angle this into the light, you might be able to see on the edge of the metal the remains of those little half-etched tags that I cut through with the scalpel. And at this point it's worth working your way around the part, removing the remains of those tags. We want a nice smooth edge, especially on the edges that are going to be visible once the model's complete, and that may include the tops of the frames. I'm using a number 6 cut Swiss file to do this, which is very smooth, and then checking by angling it into the light to make sure that all the remains of those tags have disappeared. You sometimes get a little cusp along the edges of the etched metal as well, where the metal's been etched away from both sides. It leaves a little line along the middle of the edge, and removing that is a good idea too. It adds to the visual appeal of the finished part. And I find this quite therapeutic, just working my way around. I'm hardly pressing on at all. I don't want to remove any of the shape of the metal, just any of the bits that are protruding. When I'm done, I'm going to offer this part up to the footplate to see how it's going to fit. This kit was actually designed for the older Graham Farish model, not the new EFE one, so some modifications are inevitably going to be necessary. The top of the frame should actually line up with the top of the footplate, so I can see an area of the footplate here that I'd actually like to remove and make into a hole, and a little bit on the back of the frame is going to have to be removed as well. So I'm going to mark these out for removal by drawing on them with an indelible pen first of all, and then I can scratch using my digital calipers a measured amount, and this is the depth of the footplate, which is 1mm. Then I can put the part into my vise and file down to that scribed line. Normally this watchmaker's vise fits in a shoe that's screwed firmly to my bench and doesn't wobble around like this, but I've removed it just to make it easier to film what I'm doing. So with the frames modified, the next step is to fit the phosphor bronze bearings that the axles are going to run in. These are flanged, and the flange needs to go on the inside of the frames, which is the side with the half-etched fold lines. I began by applying some flux to where the joint's going to be made. I'm using a plumber's paste flux. I know some people hate that for model making, but I really get on well with it. And then I've cut a small piece of solder from the end of a wire to give me just the right amount for the joint I want to make without leaving a mess. My soldering iron is a 50-watt temperature controlled iron set to about 350 degrees, and I'm using a fairly chunky tip for this so that enough heat gets transferred quickly to the joint. It's now just a case of repeating the process 4 times for each of the 3 driven axles and also the gear axle. And if I turn this over now, you should be able to see where the solder has travelled through the joint with a little telltale flash of silver around the outside of the bearings. So having completed both frames, I'm now going to take a much coarser file. This is a number 2 cut Swiss file, which is a bit chunkier, and I'm going to file the bearings flush with the outside of the frames. So remember, the flange is on the inside, the thin part of the bearing pokes through, and I just want to take that back. I can feel with my fingernail how much of the bearing is still protruding, and once I've got nearly flush with the coarse file, which removes material quite quickly, I can then change to a number 4 cut file, which is a little bit smoother, to get a better finish on these bearing faces. I mentioned earlier that this kit comes with a second set of frames that provide an option for doubling the thickness of the main frames, and I've cut one out just to show you how they fit over the flanges of the bearings on the inside of the frames like this. My personal take on these is that they're not actually necessary for strength, and they do make the frames thicker than prototype. Because I want the frames to be visible on the top, I've decided I'm just not going to bother with them. So, having made the decision not to double up the frame material, I need to use the wider of the 2 frame spacer strips. And the first step in preparing it is to cut some electrical isolation gaps in the copper clad on both sides of the material. I'm using a razor saw to do this, extending these gaps as I go along. And then I'm going to use the same method I use with the frames by using ink and then my digital caliper as a scriber to mark off the lengths that I need for the spacers themselves. I'm going to need 4 spacers for this model, and the lengths of them are given in the instruction sheet, which you can download from the association website. By running the saw against the edge of the vice jaws like this, I'm guaranteed to get a nice square cut, but I still need to go quite slowly and carefully because this material is liable to break, especially the copper clad can peel off quite easily. And you can see on the corner of this piece I've got a little edge that's broken with the last cut of the saw, so I need to put it back in the vise and just square it off with a file. With all the spacers cut to length, the next stage is to tin the copper surface on both sides, so I'm preparing some piece of solder to do just that. So these are my 4 spacers, with sizes predetermined, and I'm using the same flux again on the end of a cocktail stick so that I can control where it goes. The design of this chassis is obviously being thought about very carefully because it has some really nice features, such as these flaps that fold down to help position the spacers. They also need tinning, which is what I'm doing now, so that later I can sweat solder them to the surface of the PCB spacers. I'll start by fitting what I think is probably the easiest of the spacers, which is the long one that goes under where the cab floor and bunker will be. I can clamp it in position with tweezers, and where it sticks out at the front of the flap, put a little fillet of solder to join it to the frame. And then with a bit more flux to make sure that the heat flows from the iron, I can heat from on top, and where those 2 areas were tinned underneath, the solder will fuse together. And before I put a seam of solder along the bottom edge of this frame spacer, I want to make sure with the set square that it is absolutely perpendicular to the frames. Getting this wrong at this point and carrying on will result in wonky frames later on, so it's worth taking a bit of extra time to make sure everything is square as you go along. I'm going to repeat the process with the front spacer now. There's a third spacer that goes in the middle of the frames, and the tabs fold up from the bottom for this, and the spacer sits on top of them so that it still stays hidden between the frames. I found this one a bit more tricky to solder in place, and you can see that I didn't get it quite right at the first attempt. It's ended up sitting at a rather jaunty angle, but no worry, that's the joy about soldered construction. You can remelt the solder and adjust things to your heart's content. So clamping it with tweezers again, as the solder melts, I can just squeeze it up to that platform, and hopefully that's looking a lot better. The final spacer's a little bit different because it goes vertically and therefore it can't have a fold-up ledge to sit against. So I'm going to tin the frame behind it to make sure I can get a good joint. And then it's a case of holding it in place and putting a fillet of solder to join it not just to the frame but to the horizontal front spacer as well. Now, when it comes to joining the two frames together, you can use the fold-up box contraption that comes as part of the etched kit. The frames slot into it, and lengths of axle steel go through the holes in the frames of the jig and hold everything nice and square while you solder it together. However, I already have a set of these universal frame assembly jigs that are sold by the association, and so my default is to use these instead. Before I fit the second frame into the jig, however, I do need to prepare it by tinning and folding down those tags that are going to support the spacers. The frame can then slide onto the jig axles and we can test that everything fits nicely together as it should. The other end of the bobbins can then screw on to hold everything in position. Not too tight, we're not trying to crush the frames, just hold them in place while we do the soldering. The initial assembly is something of a dry run just to check everything's square and aligned the way we'd expect it to be, and then I need to slacken the jig off and put a bit of flux underneath where those tabs fold over so that I can sweat them onto the frame spacers. Even with these frame assembly jigs tightened up, it's still possible to twist the chassis, and so to avoid building it in a twisted state, I'm going to pop the jigs into the vise and make sure that they're held parallel to each other. and with the edge of the frame lying along the top of the vise nice and flat, I can make sure that the frame is not twisted and not bent as it gets soldered together. This is one of those instances where being able to take the vise out of the shoe and hold it at different angles on the bench is helpful, not just for taking videos, but also for getting the soldering iron into all those awkward nooks and crannies. Once again, when all the soldering's complete, it's worth spending a little bit of time making sure everything is square and everything is straight. Having to unsolder something and redo the job now is a pain, but not half as much of a pain as when the loco's complete and you find it just doesn't run. A good way to check there's no twist in the chassis is to take two long pieces of axle steel, put them in the front and rear axle holes and look along the chassis to make sure the steel is absolutely parallel. And my final check is with a steel ruler along the edge of the frames, checking both sides to make sure that they are dead straight. On the frame support at the back of the chassis, there's a little extension piece with a hole in it that marks the location of a fixing bolt. Bearing in mind that this chassis kit is for a different version of the locomotive, that fixing hole is probably going to be in the wrong place, but just because it's there I decided to drill it out anyway, something that I would later come to regret. If you're worried that I'm drilling at a bit of a crazy angle here, I'm actually not, it's just the effect of the barrelling of the camera lens. I'm even going to the extent of countersinking the hole from underneath, just to accept a little black screw that came out of the bottom of the chassis. And once I'm happy with the hole, I need to remove that tab extension from on top, cutting it through with a knife, and then it can just flick away so that I'm not risking electrical shorting across the top of the chassis. Now that the frames are assembled nice and square, I can begin to add some of the details. And I'm going to start with the sandboxes, which fold up from one piece and then fit into little slots in the frames. As you can see, they're quite fiddly, but sometimes it's easy to forget just how small 2mm scale is. The important thing is to make sure all the folds are at right angles so that the corners line up neatly. I'm going to put a generous amount of flux and a decent lump of solder into this folded up carcass, and when I apply the iron, the flux and capillary action will take the solder up into all those joints, and from the outside it'll be very neat. There are a few different ways I could approach fitting the sandbox to the frame itself. I'm not going to tin the frame because I don't want to fill those slots up with solder. Instead, I'm going to generously flux the frame and the sandbox and introduce the solder on the iron from the outside. Then by putting the iron inside the box, that solder will draw through from the outside and should, with the flux, wick all the way around and leave me a fairly neat joint with a little seam that you can just see glinting in the light, where everything's joined nicely all the way around. To do the other one, rather than introduce the solder from the outside, I'm going to put it on the inside and then apply the iron the outside to draw it out. The solder always goes from where it is to where the heat is. While I'm busy soldering things to the frames, I'm going to add some cross rods for the brake hangers, and these are made from 0.3mm nickel silver wire. It's best to make them over length and then cut them back later so they're easier to handle. And what I'm aiming for with my soldered joint is a little volcano shaped bit of solder going up the inside where the iron's been, and then if I check on the outside I should see the little glint of silver where the solder's come right through the joint. The centre and rear brake hangers were quite straightforward, but the front one is tight up against that frame spacer, and I've had to scrape away some of the solder and go in with the drill where it had filled up the holes in the frames. In the end I had to resort to putting it on in two pieces and solder it to that front frame spacer. Before I go much further with the chassis and things start getting awkward, I want to try and fit it to the footplate nicely. At the front end, the chassis is level with the bottom of the footplate, and in the middle it's a millimetre higher, which should come up level with the top of the footplate. Offering the two parts together can confirm that that height difference is just right, which is a stroke of good luck for me. If we look at the top of the footplate, this area that would be between the frames is what I want to remove. It's got some moulded on detail, but it doesn't look like any Austerity locomotive I've ever seen in real life. The width of the gap in the footplate in the firebox area is almost exactly the same as the width of the frames, which is another stroke of good luck, and hopefully I'll be able to extend that gap forwards. A piercing saw is the ideal tool for this job. I can thread the blade into the hole and I should be able to quite quickly cut out a rough shape and then file it to finish. To support the footplate while I'm doing the actual cutting, I'm going to use this jeweler's bench peg. Unfortunately, things do still seem a little bit precarious because of all the bits dangling down from the footplate. It can't really sit flat on the peg. But by going slowly and taking lots of care, my goal is to cut this shape out without snapping the footplate in half. After what feels like days of filing, I've finally got a nice smooth hole which is the correct width, but unfortunately I've got two problems. Firstly, the hole is not long enough, and secondly, there are some plastic sandboxes glued to the underneath of this footplate which are interfering with the etched metal ones that I've just soldered onto the chassis. They're glued on very securely and a bit of brutality is called for in removing them, but eventually they will come away and no damage is caused. This pillar for fixing the body to the original chassis is also in the way of one of the frame spacers, so it needs to be removed as well. On inspection, it's becoming apparent that the chassis needs to move forwards relative to the footplate, and I'm going to do that by filing that slot a little bit longer at the front end. The overall length of this chassis is slightly shorter than the gap between the two buffer beams, so I am going to end up with a little space that needs filling in at both ends. However, I want to line it up so that the axle holes are exactly underneath those recesses that you might be able to make out in the bottom of the footplate, which are there to accommodate the wheel flanges. I'm happy now that the frames are in the right location when they're tight up against the front of that hole in the footplate. However, at the rear end they still don't quite fit. I could extend the hole backwards to accommodate the frames, but that would take away some of the material of the cab floor and I don't want to do that. So instead I'm going to take a little bit off the back end of the frames. and eventually the chassis plugs into the footplate with a nice snug fit. Fortune is smiling on me once again, as those frame extensions fit perfectly in between the sides of the firebox. I'm going to have to think quite carefully about how the motor will connect to the rest of the gear train, but that's not something I have to worry about immediately. You can see quite clearly here those gaps around the rear end of the frame especially that'll need filling in at some point as well. But my immediate concern is securing the footplate to the frames to make a solid unit as a foundation for the rest of the locomotive. I'm using a small drill through the rear footplate fixing hole here to make a mark on the rear frame spacer, and we'll see how far out the original hole that I drilled was. It's quite close, but unfortunately not close enough, so I'm going to have to put a new hole in there and probably extend the original one into a slot so that I can screw from the underneath up into the original mounting point on the footplate. When it comes to the front end, if you remember, I had to cut away the fixing stem that originally protruded from the underside of the footplate. So I'm going to drill a hole in the front frame spacer, and I'm aiming for this to line up under the fixing stem that pokes upwards through the smoke box, and to my eyes looks a little bit like a blast pipe would if this were a real engine. I need to be careful to pick away any loose little bits of copper that have peeled back where the drill poked through. I don't want there to be any risk of short circuits. Now I'm just marking with the drill where the screw needs to go through onto the underside of the footplate, and I can change to a much smaller drill to drill a hole that hopefully the screw that came with the loco will be able to tap its own thread into. Now I've reached the point where I can assemble the frames and the footplate together securely, I think that's a good place to take a break. Join me again in part 2.